Okay, welcome everyone to new video about conditional probability. Okay, so in this video we will look into this question number 1. So you are given probability of A as 0.35, probability of B as 0.45 and probability of A and B intersection. Probability between A and B as 0.13. Okay, asking you to find out probability of A dash given B dash. Okay, if we write the equation for this one, probability A given B, you can write probability A and B divided by probability of B. This is how we write it, how we write the equation for the conditional probability. Okay, but this is not they are asking. What they are asking is probability A dash given B dash. Same as the previous, write the equation, then it will be probability A dash intersection B dash divided by probability of B dash. This is the equation for that. Okay, now what you should know when you are solving this question is the complement of an event. Okay, PB is given as 0.45. PB dash will be then 1 minus PB, complementary events. You know that probability of A plus probability of A dash should sum up to 1. Right? Same theory. So 1 minus 0.45. So this is 0.55. Okay, we found PB dash, this one, 0.55. Okay, next is getting this one. Okay, this is something you might forget always, but A dash and B dash, common area for A dash and B dash. Okay, let me draw the Venn diagram for this one. This is A, this is B. Now, if I color the A dash will be area that does not belong to A. If I color the B dash, that means the area that does not belong to B. It is this. Okay, now what they are looking for is A dash common area and B dash. Common area for A dash and B dash. Common means you should have colored that area with 2 colors. That is the common area. That means where you see red and green both, that will be A, O, B dash. Why? These circles, both the circles are AOB, right? Both the circles are AOB. Except that one, that is the complement of that union, AOB, that will be the area that holds both colors. So this one is equals to this one. So you can convert that into probability. That will be this one. Okay, now to get this one, this is 1 minus probability of A or B. Why? Probability of A dash will be 1 minus probability of A. Same as that, probability of A or B dash will be 1 minus probability of A or B. That is the theory, right? Same thing, same content you should repeat here. So now what we are going to do, we need to find out this one. To find out that, you can use the addition theorem in probability, right? Probability of A or B, you can write as probability of A plus probability of B minus probability of A and B, right? So this is 0.35 plus 0.45 minus 0.13, 0.80 minus 0.13. So answer for this one 0.67, right? 0.67. Okay, we got this one. Now that is probability of A or B, not the probability of A or B dash. Now to get that, substitute your value here, 67, so you will get 0.33. Now you know this one. This is, so this is 0.33, therefore this one is 0.33. So that means this is 0.33. Now you have all you need. You just need the division. 0.33 divided by 0.55. You can go with 3 divided by 5. 0.6. Okay. So answer for this one is 0.6. Okay. It was lengthy but detailed, right? Okay. Okay, let's move into the next part, B. Explain why the events A and B are not independent. Okay, if two events are independent, this is the theorem. Probability of A and B should equal to probability of A into probability of B. If A and B are independent, this is the rule. This should hold. Okay. So let's check. Let's get the left hand side. So the left hand side is probability of A and B. This is given as 0.13. This is given. Okay. Let's get the right hand side, which is PA into PB. So this is 0.35 into 0.45. 35 into 45, you will get the answer 0.1575. Okay, now for the independency, A and B, probability of A and B should equal to probability of A into probability of B. But based on this one, you see 0.13 is not equal to 0.1575. Therefore, A and B are not independent. Okay. Nice. So that way you can say A and B are not independent. Next thing is asking you, now they have given some additional details. Probability of C, there's something called probability of C, which is 0.2. And also they have given some more details. Events A and Z are mutually exclusive. And events B and C are statistically independent. Okay, what does that mean? Probability of B and C is equal to probability of B into probability of C. Because B and C are independent. Okay. Now, asking you to draw a Venn diagram to show these events A, B, and C. You know P, A, and B. This one is 0.13. From this one, you can calculate probability of B and C. That will be 0.45 into 0.2. This is 0.09. Right? Yes, because of the independency, we can get it as probability of B into probability of C. Okay, 0.09. What about this one? A and C are mutually exclusive. What does that mean? Mutually exclusive means probability of A and C is equal to 0. Mutually exclusive. Okay. Because of this one, probability of A and B and C, this also becomes 0. Why? A and C are mutually exclusive, then you cannot have a common probability for all three events. 2 by 2 you can have. Okay, let's look at how we can draw the Venn diagram for this one. This is A and this is B. Then A and C are mutually exclusive. So, but B and C, you can get the value. This is C. Okay, the common probability A and B, here it is 0.13. And probability of B and C is 0.09. Probability of A is 0.35. Probability of B is 0.45. Probability of C is 0.2. Okay, you can write them on the circles. So A only will be here. That will be 0.35 minus 0.13. This is not A dash. This is not A dash. A only. A only 0.22. To get this one, B only, that is 0.45 minus 0.13 minus 0.09. So this will give you 0.23. Next one is very easy. C, 0.2 minus 0.09. So you will get 0.11 for that. Okay. Now, outside the circles, you have to fill that one also. So the outside means this area that does not belong to the circles, any of circles. Okay, here 0.2 should be on top of the circle C. Okay, on top of the circle C. So let me write it over there. It should be 0.2 here. Okay, this is 0.11. Okay, now let's look into the outside area. Again, you know the outside area will be 1 minus 0.22 minus 0.13 minus 0.23 minus 0.11 minus 0.09. All individual sections addition. Okay, this should be equal to 0.22. That means the outside is 0.22. Okay, if you are confused with that one, what you need to do is get all the circle area. Get all the circle area. Do 1 minus all the circle area. Okay, when you are getting all the circle area, the entire circle area thing, consider individual probabilities. But still, there's a possibility that you can do something like this. 1 minus 0.35. This is entire A, including P, A and B. And then you can reduce 0.23. Okay, 0.23. And you can reduce 0.2. The entire C thing. That includes B and C also. Okay, same. So you will end up with 0.22 as the answer. Next thing is find P, B or C dash. probability of B O C dash. This is 1 minus probability of B O C. This is something you know now, complement theory. Okay, probability of B O C, you can get it from the addition rule. Probability of B plus probability of C minus probability of B and C. Okay, probability of B is 0.45 plus 0.2 minus 0.09, right? This one, the common probability between B and C, right? The common probability between B and C. So this will give you 0.65 minus 0.09. So if you get the answer for that one, this is 0.56. Okay, now what? This is not the thing they are looking for. This is what they want. 56. So 0.44 will be the answer. So that's it, and thank you very much for watching.